Welcome. Today we will look at the Algebra 2 Common Core Regents, the one that was issued in January 2017. We'll be looking at one problem at a time and we'll see what is the best case or what is the best strategy to approach every single problem here. Alright, well let's get started. Let's look at example 1. It says relative to the graph of y equals 3 sine of x, what is the shift of the graph of y equals 3 sine x plus pi over 3? So notice that here we're looking for the shift. And to identify the shift, you need to identify the difference between the original and the function that the shift occurs. So notice that the only difference between the original function and the shift is right here. Because everything else besides this term, it's pretty much the same as the original. So the shift occurs because we added a pi over 3. Now, because you add inside, the sign, so that means that the shift, whoops, don't know what happened there. Because you add inside, then that means that the shift is 3, or it's pi over 3 units, because that's the number that we added, to the left. And that's going to give us option 2 here. So now, if we were to subtract pi over 3, if this would have been a subtraction, then we would have moved to the right. Now, if we would have added outside the parentheses, we would have moved it up. And if we would have subtracted outside the parentheses, we would have moved down. But right here, we're adding pi over 3 inside the sine function. So that means that our shift is going to be 3 units to the left side. Okay? Now, let's look at example 2 here. And it's a word problem, so let's analyze it. It says a rabbit population, it doubles every 4 weeks. Now, we know that there are currently 5 rabbits in a restricted area. Now, here t represents the time in weeks, which is important. And p of t is the population of rabbits with respect to time. Now, the question is how many rabbits will there be in 98 days? Well, look at what's going on here. We know that a rabbit population doubles every 4 weeks. So we know that it doubles every 4 weeks, but we're interested in 98 days. So there's a conflict of units there. So let's see. How can we represent 4 weeks in days? Well, we know that in every week there's 7 days. So 4 times 7 is going to give me 28. So that means that in 4 weeks, there are 28 days. Okay, so all we did, we just converted this 4 weeks into days, right? So 4 weeks, there's 28 days. That's about it. But now, let's see. When does the rabbit double? We know that the rabbit doubles every 4 weeks, which we know is 28 days. So every 28 days, the rabbit will double. And we're looking at 98 days in total. So let's see how many times are my rabbits going to double. So we have 98 days. And we know that it doubles every 28 days because it doubles every 4 weeks. And we know that 4 weeks is 28 days. So that means that in 98 days, our rabbits will double 3.5 times. Okay. Well, now, with this information, we can have a better sense as to what's going on here. So according to the problem, we start with 5 rabbits. And now we know that it's going to double 3.5 times. So if it's 5 and it will double, well, now you're going to have 10. And if it doubles again, you're going to have 20. But notice here, we have double once, twice. All right, so we can still double once more. So that means that our next one is 40. So this is my third double. But notice that here we have 3.5 times. So I guess let's see what happens when we do the next one. So here we have 4 times the doubling. But we know that it's going to be doubling 3.5 times. So that means that my answer is going to be somewhere between the third and the fourth doubling. So that means that my answer is going to be somewhere around here, which, just by looking at my options, it seems like the option that fits this description, it's option 1. Okay, well, let's look at example 2 now. It says, when factored completely, m to the fifth plus m to the third minus 6m, what is this equivalent to? Well, let's write down our function here. Let's start working on this. So m to the fifth plus m to the third minus 6m. One thing that we do notice is that every single term has an m on it. So let's factor out that m. Factor the m. Now we have m to the fourth plus what is this? M to the second minus 6m. No, just regular 6. All right, perfect. So now all we did, we noticed that I have a factor, we factor it out. So now let's see, can we factor out the inside? Well, for that, we can use the x method, where the x method says, let's look at two numbers that if you multiply, gives you negative 6, and if you add them up, gives you 1. Well, if we look at these numbers here, we will see that the numbers that we're looking for is 3 and negative 2. Well, let's check it. 3 times negative 2, that's negative 6. Cool. 3 plus negative 2, that's 1. All right, so that means that the inside, we can factor it out as m squared plus the first number that we found out, which is 3, and m squared, and the second number that we use, which is negative 2. And if we look at the options that we have here, you will see the correct option is option 4. Now, let's pause here for a second, because maybe you're not familiar whenever there's a fourth exponent. If we would have our problem as m equals m squared plus m minus 6, which maybe this is something that you're more comfortable factoring quadratics. If this would have been the case, if we would have used the same x method, we would be able to write it as m plus 3 and m minus 2, close parentheses. But notice like here, when you multiply this, m times m, that's m squared. That's why we're able to write it as just regular m's. But here, this is not the problem that we have. Here we have m to the fourth. So all we got to do is still use the same method, but instead of writing m, we're going to write m squared. That's the only difference here. And we will see that the correct option is option 4. So we move on. We're going to see that example 4. They're asking us if the sine square of 32 plus the cosine square of m equals 1, then what is the value of m? So here we want to see what is m. Okay. So the first thing that we want to notice is this. Let's rewrite this function, because I personally do not like to write it this way. I prefer to write it the following way. Instead of putting the second exponent in the middle, I'm going to put it outside. And the same goes for the second expression here. Okay, perfect. So all we did, we just rewrote it. But notice that here we can find the value of this. Using our calculator, we can see that the sine of 32, well, before I press enter, make sure that your calculator it's in degree mode. That's great. So the sine of 32 is equal to 0.5299. But we want the sine 32 squared. So let's just square this. So that means that sine 32 squared is equal to just 0.2808. I'm just going to use 4 decimal places there. So plus equals cosine of m equals 1. So and again, we want to solve for m. So the first thing you want to do, make sure you get the cosine by itself. So in order to do that, let's subtract negative 28 minus 0.2808. And notice that when we do this, we are going to have the following. We're going to have cosine square. So now 1 minus 0.28. So we're going to say 1 minus 0.2808. We're going to have 0.7192. So notice that we almost have it by itself. We have the second exponent. And in order to cancel out the second exponent, we take the square root. Okay, perfect. Let's continue our problem here on the side. So now we have cosine of m equals the square root of 7192. I already did this. You can do it in the calculator, but this is equal to just 84, 80. Again, we want to solve for m. So now we're going to cancel the cosine. And in order to cancel the cosine, we got to do the inverse. We multiply the inverse to both sides. Because when you multiply by the inverse, this cancels out. And now you have that m is equal to the cosine inverse of 84, 80. Let's find that out in the calculator. Second cosine inverse. I'm sorry, it's a decimal right here. 0.8480. You will see here that we have 32.00, which is pretty close to option 1, which is 32. Now again, we're not getting the exact answer because here, instead of writing the whole number, I just wrote 4 decimal places, so we're getting an approximation, which is exactly right here, 32 degrees. So that means that m is equal to 32 degrees. Perfect. Let's look at example 5 now. Just give me 1 second here. Let me make it smaller so it all fits on the screen. All right, so here, in example 5, it says, what is the solution to the system of equations y equals 3 minus 2 and y equals g of x, where g of x is defined as a function below. Now, here we're being asked, what is the solution of two functions? And the solution occurs, so let me write this down because this is important. The solution occurs oops, when the two functions meet or they intercept. Okay, so we have this function. Now, if we graph the function that we're looking for here, y equals 3x minus 2, well, let's see how that looks like. Well, we don't even have to use the calculator here because we can see that the y-intercept is negative 2. And we can see that the slope is 3. So we're going to go 1, 2, 1, 2, 3, and 1 to the right. And we know it's a straight line, so we only need 2 points. So let's just connect those dots. And, well, let's see. And again, right here, the red function, this is the y equals 3x minus 2. You can put in the calculators for you to know that this is the actual function here. Now, let's see, when are the two functions meeting each other? We know that it's going to meet right here. And this coordinate point right here, this is 1, 1. So we know that there's a solution at 1, 1 because that's where they're meeting each other. And then option 4 is the actual option that has 1, 1 as a solution. Now, 6, 16, it's not displayed here, but in order that this function keeps going up and this function keeps going this way, they're going to meet somewhere around here. And that is the other point, 6, 16. But we know for sure that they're meeting at 1, 1. So here, option number 1. I'm sorry, option number 4. Perfect. So moving on. Here, let's look at example 6 now. Now in example 6, it says, which statement about a statistical analysis is false? So take a closer look, and here we're looking for false statements. So let's look at each of those statements here. The first statement says, experiment can suggest patterns and relationships in data. Well, actually, that is the purpose of an experiment. You do experiments to kind of see a pattern and kind of see relationships. So I know this is true. Now, second option says that the experiments can determine the cause and effect of relationships. And again, that's the purpose of an experiment. You want to see a pattern, and if you see a relationship, you will see some kind of a cause and effect. So actually, statement 2 is true as well. But again, we're looking for false statements. So let's look at a statement 3. It says, observational studies can determine cause and effect. Now, Here it is saying that it can determine cause and effects. But now, what the observations do is give us some kind of a idea as to what's going on, but the experiments are the ones who can determine cause and effect, are the ones that give us a better understanding as to what is a cause and effect. Observations cannot do that. So this is a false statement. And again, the observation studies can suggest patterns and relationship in the data. That's actually the purpose of an observation. So let's look at example 7. In example 7 here, we have, well, if you've been given the following, this expression, what is this equivalent to? Well, here, let's use this space so we can answer this question. So let me write down the problem here. We have m squared over m to the 1/3, and all this to a negative 1/2. Again, let's remember our order of operations. You first want to work with the parentheses. So notice inside the parentheses, you are dividing. And the rule of exponents says that if you're going to be dividing, you're going to be subtracting the exponents. So now here, what we're going to have inside the parentheses is going to be m2 minus 1/3, negative 1/3. And again, we are subtracting because that's what the rule of exponents says. So we subtract. So now what we end up here is going to be we're going to have 5/3 to a negative 1/3. Okay, so now again, what does the rule of exponents say? Well, it says that if you have an exponent here, you have an exponent outside as a parenthesis, you can distribute as multiplication. So now we're going to have we're going to have 5/3 times negative 1/2. And if we multiply this correctly, you will see that you have negative 5/6. Because again, 5/3 times negative 1/2, 5 times negative 1, this is negative 5. 3 times 2, well, this is 6. Perfect. So now we have the following. But now look at the following here. None of the examples here are written as negative exponents. So we got to rewrite the exponent because it's negative. And when you have a negative exponent and you want to write it as positive, all you got to do is just put over 1. So now this becomes 1 over m, 5/6. But still, look at the following options here. None of them have exponents, but at least we can eliminate option 3 and option 1 because it's not over 1. So it's either option 2 and 3. So which one is it? All we got to do is just rewrite it into square root form. So this becomes 1 over. Now, again, when you rewrite in square root form, the denominator is your root. So we're going to have a 6th root. And we're going to have m to the 5th inside. And if we look at the options correctly here, we will see that it's option 2. Okay, so let's look at example 8 now. Example 8 is asking for the following. What is the inverse? What is the inverse of the function y equals log 3 of x? Okay, when we're talking about inverse, always the first step is switch your variable. Because you're looking for the inverse, we got to switch the variable x and y. So this is the original function, y equals the log of 3 of x. Now, if you want to find the inverse, we got to switch the variables. So now this becomes x equals the log of 3 of y. We switch variables because we're looking for the inverse. So now we got to solve for the new y. But notice that the y is right here, inside the log. To go inside the log, we're going to apply the rule, the definition of the logarithm, which just says, well, this 3 is going to be your new base. So we have 3. And the 3 is going to have some kind of an exponent. And this exponent is located on the opposite side. So it's going to be 3 to the x. And that is going to be equal to what we have inside the logarithm, which says this is equals to y. But notice that we have solved for the new y, so this is the inverse function here. And if we look at the options that we've been given here, we can see that this is option 3 right here, man. Perfect. So now let's look at the following problem here, which is example 9. Example 9, where's that at? It's right here. Okay, so in example 9, it's a pretty lengthy problem. A lot of words here, but let's just make it smaller so we can actually fit it. Okay, perfect. It says that Gabriel performed an experiment to see if planting 13 tomatoes plants in black plastic mulch leads to larger tomatoes than if 13 plants are planted without mulch. He sees that the average weight of the tomatoes from tomatoes plants grow in black plastic mulch was 5 ounces greater than those. So you can read the story on your own. But now, what we're going to be more interested on is right here on the data, which it says, given these results, which they've been displayed here, what is an appropriate inference that can be drawn? Okay, for here, the option that stands out the most is option 2. Because option 2, it says that there was an effect observed that could be due to the random assignment of plants to the group. Now, why is this true? Every time you do kind of one type of an observation, or if you want to do some kind of an experiment, your observation should be done in a random manner here. And if you look at the 4 options, this is the only option that actually talks about the process of you picking a random, or you picking a random member in the sample here. So because of this is the only option that actually talks about randomness. The correct option is option 2. Lastly, for this video, we will look at example 10, which says if p of x equals abx and r of x equals cdx, then p of x times r of x is equal to. So pretty much this is saying what happens when you multiply the two functions here. Well, let's take a look. This is what the problem is asking us, p of x times r of x. We know that p of x is abx. So we have a bx times, but we know that r of x is equal to c dx. So we have c dx. Perfect. So now if you're multiplying, you can multiply the outside. So we're going to have a times c. But notice that here b and d, they have the same exponents. So you can rewrite this as bd to the x. Now, why is this true? Because, well, if we have b of d to the x, this x can be distributed to both of them. And now you have b dx times dx, which is exactly what we have here if we were to multiply. So that's why we are going to be able to rewrite it in this form. And if we look at the options that we've been given here, we can see that the correct option is option 3. So this concludes part 1 of 4 parts that will cover the whole Algebra 2 Regents for January 2017.